All right. So, homework assignment. We were. Is this our class? Okay, yeah. So we had what four functions, four methods. One of them was what? Remove vowels, remove consonants, remove digits, and then the parse expression. Is that the? Okay, so the first three were easy once you figured out one of them. All right, so let's, and I think I gave you some hints too, right? All right, so let's just get all this stuff. Don't need any of that. Okay, so we're supposed to have a function called remove vowels. Is that the first one? Okay, so we're going to say static. Huh?
You wanted to print the vowels in a string.
Is that what it's called? Print vowels?
Print vowels, yeah.
Okay, so print vowels, and it takes a string as a parameter and only prints the vowels from the string? Okay, so that means this guy doesn't return anything. All right, so like this, and this guy takes in a string S. So it's print vowels, print consonants, print digits. Okay, so we're not returning a string, we're taking a string in and displaying portions of the string. Okay, got it. So print vowels takes a string S in. I'm going to go ahead and I'm going to create a string called map here. And I'm going to put in here A-E-I-O-U, A-E-I-O-U. So I've stored in there all of the vowels. So now what we're going to do is we're going to go through every character in S. I is equal to 0, I is less than S dot length, I plus plus. So this is our stock loop that goes through every element in this case, the string S, right? And the way we access an individual string is by saying S dot, or individual character in that string is by saying S dot char at I. And now I'm going to use map to look up the individual character inside of map. If it gives me something other than a -1, that means it's a vowel, right? So we're going to say if map dot index of S dot char at I, if that value is something not equal to -1 or something greater than equal to 0, however you want to put it, then we'll say system dot out dot println S dot char at I.
Dumb question.
Mm-hmm.
In the if map dot index of,
Yep.
instead of doing it like that with the string map, could you just in front of the index of just put your character sets you want to search for just in there?
Yeah, you can put that. I'm going to turn this around on you. So you're asking, can I do that instead?
Yeah.
The answer is yes. Now you tell me why. Based on what we talked about last time.
Why can I do that?
Yep. Why are we allowed to do that?
Well, because we know index of, we're searching, we're
Yeah, but
telling index of what this.
Why can I replace map with that? Why are those synonyms?
It's still part of the string that you're searching for. You're feeding the string from up above.
Yeah, but I'm not feeding a string from up above.
Well, no.
This is a string. I took map. I don't even need map now.
No. Oh yes, yes. No. So up above, what I did up above then is I did like I mapped the static void print vowel to say whatever, say.
Yeah, I get it. I'm just asking, why am I allowed to do this rather than storing it in a variable first and calling out the variable? Why am I allowed to do that? Why is it legal?
Because you're declaring the variable right in there.
So you're telling me, you're saying that this is a variable? If I do this, that's a variable? What is this guy? What kind of? If you saw this in the wild, roaming around, how would you identify that? What is that? Okay, it's a string? Is it a variable? So she said it's a string. I would say it's a string literal. Same thing. String, literal, fair enough. All right. are variables? What makes something a variable, and why is this not one of those?
Well, variable is something you declare, like what you're doing above with the string math. That means I'm declaring that variable.
Okay, so what makes this a variable? So I declared it, but specifically, what are the features that we would say a variable has?
It is associated with something like integer.
Yeah, it holds a value.
Yeah.
Holds a value, something like that, right? Okay, fair enough. So then my question is why am I allowed to do that rather than being forced to use a variable to call that index of? Index of is a what? What kind of animal is this guy? Cat, dog, variable, method. Those are the options. Cat, dog, variable, method. Which one of it? It's a method. Okay, how do you know this is a method? What are the attributes of this guy that allows you to visually identify it as a method? Okay, yeah, the parameters. Yeah, not all methods take any parameters, but they all have the parameter list, the open and closing parentheses. So we know that this guy is a method of some type. We're going to talk about the different types of methods probably today, but for us right now, a method is a method. Okay? So we know this guy is one of those because of the open and closed parentheses. Last time, we talked about this idea of variable resolution. What does it mean to resolve a variable? So you just finished telling me that a variable is something that holds a value. Okay? And when we resolve a variable, what happens? Yeah, we replace that variable with its value. We have to go and look up its value wherever it is, and open up the container, say, oh, here's the value, plop it down here, right? So at runtime, when we resolve map, won't it ultimately resolve to that exactly?
Yeah.
That's exactly what it'll resolve to. Now, the interesting thing here is it's fairly common for people to look at something like this. Let's just say hello. And string s is equal to hello. And I'll do system.out.println s.length. And then I'll do a system.out.println hello.length. Both of those work. If I run this, we're going to get 5 and 5. Okay. S resolves to its value, which is that string. That guy has a length of 5. Same thing as saying this, except it's not stored in a variable. This is a literal, so I can't then later on go and change S. That makes sense? At the end of the day, many programmers are uncomfortable with doing something like this. Now, doing something like that might not make a lot of sense. Right? Why say hello.length when we could just say 5? Short enough string to probably count how many characters in it, right? Since we hard-coded the string anyways. But, you know, we don't have to. But the punchline is that there's nothing that keeps us from doing this. And we often think that, oh, well, this looks more natural. This looks more correct. When the reality is that this is the guy that's actually in costume. At runtime, this guy will end up looking just like this guy.
The reason why you would go with the first print line is because you could reuse that string S in other places. Whereas that second one, you're
correct.
That's the only time you can
Or even more appropriately for our functions here, it's S. We don't know the nature of S. Last time I was harping on this idea, how many characters are in S? S.length number of characters. We don't know what string they're going to pass to our function, right? Okay. So we're going to have print vals. It's going to take a string as a parameter. I went ahead and created a variable to hold on to that string of vowels. We went through every character in our string. Each time through, we asked about the position of the current character we're looking at in this string. If it existed in there, that is, its position was not equal to -1, then that means it must be a vowel. We'll go ahead and keep it. Make sense? So let's go ahead and call print vals. Passing it S, and this should give us what? EO? All right, so there's our print vals. consonants. Yeah, I'm going to remove them afterwards. Oh, I totally thought I had caps lock on. Okay, so that's the whole alphabet. Now we go through and just get the vowels out of there. Okay, so now this guy works for print consonants. There's HLL. And finally, steal this guy. Print digits. And that's print digits. So if I pass it S, nothing's going to print because there's nothing in there. But if let's just put some stuff in there. There's our digits from there. Make sense? So as advertised, once you figured out how to do it once, it was easy to do it for the other two, correct? Common mistakes for this one is that consonants means everything that's not a vowel, which isn't the case. So things that I would test on are like throwing question marks, things like that in there. A common mistake for print consonants is it will get everything that's not a vowel, which means it will print out ones and question marks and that kind of stuff. So these are the vowels, upper and lowercase. These are the consonants, upper and lowercase, and here's the digits. All right, questions about those three? So those were the hard part of the assignment? Okay.
Some took time to do it.
Well, sure, but only the first time you did it.
Yeah.
The first one was the time it took. And then after that, sometimes there is a confusion on the consonants one where you have to actually ask yourself what's a consonant. Digits and vowels are pretty easy. All right, so everybody's wants this written down, has it written down? Because I'm gonna, well, actually, let's do this. I pushed this to GitHub last time, right? Okay, so, well, we'll leave them in there. I'll just do the other parts up above. I was gonna take this out and then gut it for the other ones, but we'll push the solution to GitHub afterwards. Okay, so now.
You're recording now.
Yeah. Yeah.
As long as you're recording, you can always watch it. Yeah.
Hey, you want me to delete the recording?
No. I just wanted to make sure to.
No, you can always watch recordings.
All right. Well, I'll push it to GitHub afterwards, anyways. It's not a problem. Okay. So so the last one was what? Process expression. Is that the name? Takes a string as a parameter, and the string looks like something like 124 or 124 plus. Actually, no spaces, right? Plus 8.
Oh, they had spaces in there too.
Minus 13. It did allow spaces? Okay, that's fine.
You had them written out with spaces in them.
Okay, fair enough.
Like 125.
Yeah, so if I did 125 plus 1, that should ultimately boil down to the integer 126. Something like that, right? Okay. So we're going to do this in a couple of pieces. Well, several pieces, actually. So I think at the end of class last time, my hit was write lots of functions, little tiny modules that do little parts of this problem. Okay? So we're going to do that. We're going to do several of these things. So one thing that we need to do is let's just go ahead and give ourselves a sample expression. So we'll say 124 plus 18 minus 2, put some extra spaces in there, times 13, something like that. All right, so one thing we need to be able to do is if we have a string that looks like that, we need to be able to prove that we can get the 124, then get the 18, then get the 2, then get the 13. We have to be able to prove that, right? Okay? So what we need to do is we need to have a function that parses through this thing looking for the numbers. So our initial goal is we're not going to try to do any math with them. We're not going to try to do anything fancy. We're just going to grab the 124 and print it. Then we're going to grab the 18 and print it, grab the 2 and print it, grab the 13 and print it, proving that we can access those individual numbers. Make sense? Okay. So we're going to call this guy. So right now it'll be void because it's just going to print some values, but we're going to call it parse expression. And this guy will take in a string as a parameter. And we're going to use our normal plain Jane loop that goes through every element in a string. So that's a for int I is equal to 0, I is less than exp.length, I plus plus. Okay, so stock for loop that goes through every element of a string. That part should be relatively easy. Now, what the heck do we do with each element of the string is the harder part. So as we're walking through this string, things we're interested in are the things that are digits, right? So we're interested in the 1, and then the 2, and then the 4. And then as soon as we bump into something that's not a digit, it's not one of those guys, that's when we say, oh, we just found a number. Print that number for right now, right? So we need to be able to detect if a character is a digit. Fair enough? All right, well, so let's write that. Static Boolean is digit, takes a char c as a parameter, and we'll return so is digit takes in a char, and we're going to take the string representation of all the digits, call index of on that, pass it the character, and if it's something other than -1, then this guy is a digit. And we'll go ahead and return true. Make sense? All right, so that allows us to detect if something is a digit. If you weren't comfortable doing this, you could have put it inside of a variable and then said the variable .index of. Both of those are perfectly acceptable. All right, so now we have a little tool here that allows us to detect digits.
Can you do the same thing then for your expressions?
Well, possibly. All right, well, let's start off by parsing our expression and walking through, and if something is a digit, we'd like to keep it. All right, so we're going to be walking through here. So we're going to start something off called cur number. We're going to build up our answer in cur number. So as we walk through here, we're going to say, is this a digit? Yes. Add it to cur number. Is this a digit? Yes. Add it to cur number. Is this a digit? Yes. Add it to cur number. Is this a digit? No. Print cur number, then empty cur number. Make sense? I captured the 124. I'm not doing anything with it right now other than printing it. We're taking little tiny baby steps. But I've now caught it. I bumped into something that's not a digit. And now I can print cur number. Make sense? All right. So if is digit exp.charat I, if that guy is a digit, then we'll say cur number is equal to cur number concatenated with exp.charat I. Else system.out.println cur number, and then cur number is equal to the empty string. All right, so as we're walking through here, As long as it's still a digit, let's tack it on to our running number. As soon as we hit something that's not a digit, let's print it out, proving we found what we're looking for. We're going to end up doing something other than printing it soon enough, but right now we're printing it. And then we'll go ahead and zero out cur number so it's ready for the next time through. Make sense? Okay, so right now this is going to go through and it's going to print out 124, then we're going to get some blanks, some blanks, some blanks, 18, some blanks, some blanks, some blanks, 2, a bunch of blanks, and then a 13. Okay, because right now, anytime we're running into something that's not a character, we're printing out the current value of cur number. So cur number is going to get printed out as the empty string pretty often in our current rendition of this. All right, so let's go ahead and we're going to just say parse expression exp, and we'll run this guy, and we should see our individual values. So there's our 124, our 18, our 2, and then a bunch of spaces. And we never quite got to our 13. Why is that? He was stuck, right? We got here, said, is this a digit? Yes. Is this a digit? Yes. Then we ran out of stuff, which means our loop ended.
Yeah, so it never closed.
Never actually printed. So for right now, we can just go ahead and toss a print statement outside of that for loop. And now it'll get all of them. So there's our 13. Make sense? All right, so now we've proven that we can get at those individual values. Fair enough. Okay. So let's now upgrade this so that we ignore spaces. And we ignore, we talked about continue and stuff like that last time, right? Like I said, we did break, continue, return. Okay. So what we're going to do is we're going to say if it's a digit, do this. Else if s.charat I is equal to a space. Let's just continue. We'll skip double equal sign. We'll skip the this iteration through the loop and move on to the next guy. Okay. Else, we'll go ahead and print it and set it equal to 0. Now tell me, if I'm going through this guy, if it's a digit, I'm collecting it. If it's a space, I'm just ignoring it by continuing. If it's not a digit and it's not a space, it must be a what? It must be an operator. Okay, so what I can do here is I can print out my current number, and let's go ahead and print out the ops as well. So now we'll have the operators. Make sense? Ooh. So there's our operators without those spaces. So every single time we hit a space, we just did a continue, said, don't worry about this pass. We want to ignore spaces. That's what we're doing. We're ignoring it. Moving on with life. Okay. So now we have individual values. We have operators. We probably need a place to put those operators, right? Okay, so we're going to need to deal with that stuff. So what we're going to do is we're going to go ahead and store our operator. So we're going to say char op. I'm going to start this guy off as the question mark. Something that's not one of our valid operators. All right. So now, right now we're printing out our operator. So what I'm going to say is if op is equal to the question mark, that means this is our first operator, first guy we ran into. So what are we going to do? We're going to set op equal to exp.charat I. So we'll store that. And then let's just go ahead and found first op. Otherwise, if op is not currently a question mark, that means it's already another operator. So, for example, I hit the 124, I got the plus, I hit the 18, tells me to do some math, let's assume. Now I hit this next operator, the minus. I don't want to overwrite this guy if this guy currently has, I need to do the math before I can overwrite the guy. Does that make some sense? All right, so I need to know what the current situation is so I know, do I actually need to do some addition? Do I replace it with the minus sign? So on and so forth. So this is going to tell us, here's our first operator. Otherwise, if I'm in this else, I just finished reading in another number. Okay, remember the point of this else. This else says either I'm looking at digits or I'm looking at something other than digits. So as we walk through this, this is cur number, cur number, cur number. Continue, then we hit our first operator. At that point in time, cur num is the left-hand side of our next expression. We're going to have to store it for that, but as of right now, we know that's the case. And I'll show you why. But we just hit the plus sign. And the question we ask ourselves is, can we do math yet? The answer is no. Why? Because this is the first operator I've run into, and I'm not looking at a second number yet. So we're going to store this operator, and we're also going to want to keep our left-hand operand stored somewhere. Because in a second, we're going to start building up cur num again. So we're going to say string left operand. This guy will start off as the empty string. If this is my first, number here, I'm lying here. But if this is my first operator, we're going to say found first op, and then we're going to say left operand is equal to cur number, and then we'll say system.out.println set left operand to left operand. That's what we do when we hit our very first operand, our very first operator, rather. Otherwise, we look at what situation we're in here. We went through this. That's cur number. Continued. We hit this guy. Op is currently question mark, so this is our first operator. We'll store the operator, and we're gonna move this guy over to left operand. So we set our left operand, and then we want to make sure that we zero out cur number, because we're going to go and build up another number. So for that very first time through, we're going to store this guy in left operand, and then we're going to start filling up cur number with that guy. So now we have that 18. All right, so left operand is 124. Cur number is 18. Ignore, we hit an operator. We ask ourselves, is the current value of op a question mark? It's not. It's a plus sign. Current value of op is a plus sign. This is not my first operator. I currently have an operator, and I don't want to overwrite him until I've done some math, right? So we're going to say in here, doing math, and we'll print it out for right now just so you kind of see it. So we're going to say left operand concatenated with a space, concatenated with op, concatenated with a space, concatenated with, let me minimize this just for right now, concatenated with cur number. That's the math we're about to do. Make sense? All right, so we're going to do that math, store the result in left operand, overwrite op with the new op, and zero out cur number. What I mean by that is this. We read that in. He ultimately is stored in cur number. I hit my first op. I notice it's the first op. What do? I store the plus sign in op. I store the 124 in left operand, and I zero out cur number. Now we keep cooking. Ignore. Cur number, built up cur number. Ignore. Hit another operand. We drop into that else. Now we know, wait a minute, we got to do some math. What math are we doing? 124 plus 18 is the math we're doing. So the next thing we're going to have to do is figure out how to actually do that math. Yeah, that's the next step. Okay, but 124 plus 18 is going to be the math that we'll have to do. So we'll do that math, and we're going to store the result back into left operand. Make sense? Then, zero out cur number, overwrite the plus sign with our minus, keep cooking. Now we hit our next number. Cur number is 2. Ignore, 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 ignore. We hit this guy, not our first operator. So what do we have to do? We have to do math. What math are we doing? 3442, right? 142. We're doing 142 minus 2. That's the math we're about to do. So we'll do that math, storing the result in left operand, overwriting op with our multiplication, zeroing out cur num, ignore, cur num, fall out past that. Now we're outside of the loop. We're going to have to do any math that's left over. So we'll have to do a statement there. Okay. So let me just do this for right now, just so it's proven to us. So because we know the nature of it right now, we'll go ahead and do that. Inside here, we're going to print out the math we're going to do. We'll zero out cur number. We'll set op equal to exp.char@, which will be the next operator. And the idea is left operand should have just gotten replaced. So we'll just forget about that for right now. Go ahead and run this. So now we have 124, found the first op, set left operand to 124, doing math 124 plus 18, doing math this was the 18, so this is the actual doing math. It's because we didn't zero out the left operand because we weren't doing the math in it. But in any case, we see that we are able to grab the individual pieces, right? Okay, so let's say that as of right now, parse expression is about as far as we can take it because we have one really big problem. 124 here is a string. Kind of want them to be a number. Because if I take 124 and I try to add 18 to it, I'm going to get 12418. The string 12418, not the math number 142. Make sense? So we need to be able to convert a string into the equivalent integer. So that's another function. So we're going to say static int to string. And this guy's going to take a string val as a parameter. Well, let me just call it s because I'm going to end up typing that anyways probably. All right, now this guy's job is to take a string and turn it into an integer. So let's look at this. So if I have the string 124, how do I turn that into the number 124? the integer 124? Using only what we've learned in here so far. I assume this was the easiest part of the assignment? Okay. It's like a double whammy, right? The parsing is complex enough. Now you need to magically learn how to turn a frog into a prince.
But it is mathematically still not correct because we have to do like multiplication before addition or subtraction.
No, I think I say in there you can do left to right. I'm almost positive. I didn't say it in there, I said it in class. So you could assume it's left to
Like,
right.
If we will get
Can anybody vouch for that? I did say left to right, correct?
If we will do like we get a random string where there are not like multiplication, addition is first and things like that. So how we are going to get like do
Well, what I'm saying is you don't have to worry about doing multiplication before addition. Because I said just do it left to right. Whatever order you hit the stuff in, it's left to right. So not normal order of operation. I think it was in the assignment too, on the actual text.
It was. I'm not talking about just this assignment. I'm talking about like if we get real.
Oh, well, that's a much harder that's a much harder assignment. If you have to do things in the right order, there's actually an algorithm for doing that. Yeah, it uses a stack data structure, which we talk about in the 537 class. So we actually do that assignment in the 537 class. Yeah, you'd think this was hard. People drop the class over that one. All right, so I have a string that looks like this. How do I turn this guy into the integer 124? See, the problem here is that, and this goes way back to, well, way back, just 3 weeks ago or something like that, right? The problem we talked about the very first day of class. The reason why human beings have trouble becoming programmers is because we're so good at solving problems that we have trouble articulating how we solve them, right? Everyone in here can look at that string 124, and if I tell you to tell me the integer version of that, you can just glance at it and say, oh, that's the number 124. Right? Easy peasy. No problem. How did you do that? Our gut feeling is, well, I just did. It's obvious. Okay? But don't you suspect it's not quite so obvious? We're looking at a string just like the computer's looking at a string. We just instantaneously parse the number out of that string by glancing at it and saying, oh, that's the number 124. See, what happens is we become so comfortable with numbers. And today's going to be a day about numbers. Because after we solve this problem, we're going to start looking at other bases. Base 2, base 8, base 16, things like that. All right? We've become so comfortable with numbers, specifically base 10, that we have forgotten what it means for a number to be base 10. This number has 1 in the 100s place, 2 in the 10s place, 4 in the 1s place. So that is 1 times 4 plus 2, or let's do 10 times 2 plus 100 times 1, which equals 124. Make sense? Okay. So, if I can walk through this string from the end towards the beginning, this is the 1s place, the 10s, the 100s, 1000s. Multiply by 10 each time because it's a base 10 number. Okay? So now we kind of understand what we need to do to convert. We still have a couple of problems, but we're literally going to do the math that is required to make a number a base 10 number. Math that we've become so used to that we don't do it. We don't think about it. Okay? Now, out of curiosity, so I suspect that several of you had problems with this part of the assignment, right? How many of you ended up solving it this way versus some other weird, crazy way, which may or may not have included you finally cheating and just finding integer.parseInt, which you're not allowed to use, by the way. You'll lose points. But because we didn't introduce it. Isn't this, when did we learn this? 2nd grade? Third grade? First grade? Maybe before that, whenever we started counting our fingers and toes, right? Okay, so, and we have humbling moments like that with programming, because a lot of times when you see an answer, it's like, no, this still isn't easy, right? We still got some work to do. But what we did is we slowed down and said, oh, well, how did we actually turn this into a number? Well, just like this. Pretty straightforward, right? But we do have an issue here. In order for me to just haphazardly say 4 times 1, I need to turn the char 4 into the number 4. Make sense? So now I have a new problem. Let's dig down a little bit. So I have that number, I have that value, and I need to turn it into that value. How do I do that? You want to use parseInt again? No parseInt. No parseInt. Not allowed to use it.
Not, you're not looking for the value of, or no, it's not.
Only solve this in terms of what we've learned in class. These are the tools laid in the garage. Nothing special. We have the technology.
Is that what you're pointing out the index of?
The binary.
So computer is
It's pretty
reading
handy.
it as a character, so we have to do it as a
Let
value.
me ask you this. If I had this, what is the index of 4 in that string?
Number 5.
Strings start with bucket 0.
0, 1, 3.
So this is bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. So you're telling me the char 4 lives at bucket 4. Where's the char 8 live? 5, 6, 7, 8. So we can just use an index of. So if we come in here and I say static int char to int, and actually we named this wrong, right? I think you were trying to tell me that. String to int is what we actually want that to be. This guy's going to be char to int. Just return that. Now we're making some assumptions that we're only going to pass numeric characters to this. If we try to pass a to that, we're going to get a lot of negative 1s out of here, right? Okay. But if I pass it the char 4, I'll get the number 4. If I pass it the char 8, I'll get the number 8. Char 0, I'll get the number 0. No harm, no foul. So that converts a char to an integer. Not a whole lot of code, little tiny tool that we could use to our advantage, right? So going back to string to int, we want to walk this string backwards. So we're back on this slide. We want to go from the 4 to the 2 to the 1, because we know that the far right digit is always the 1's place. And we multiply by 10, multiply by 10, multiply by 10. As far to the left as we have to go, we just keep multiplying by 10. So we're going to keep track of, we're going to say int place is equal to 1 for int I is equal to S. What's the last legal position in S? S dot length minus 1. So S dot length minus 1 is the last legal position in S. We're going to keep going as long as I is greater than or equal to 0. I minus minus each time. And now we're going to have a running total. So before we put in any more variables, let's look at this. Would you agree now that we have the ability to turn something like this into something like this? We have a function that lets us do it. Okay? So as I walk through this, if I take the 4, turn it into an int, and I multiply it by the current value of place, that's doing this math right here, right? Then I multiply place by 10. 1 becomes a 10. I take the integer version of 2. I multiply it by place. I get that value. 10 becomes 100. I take the integer value of 1, multiply it by the current value of place. I get the 100. If I keep a running total of those, won't I get the number? So it's going to be a sum. Sums off at 0. So each time through here, we're going to say sum is equal to sum plus. We need to say char to int of what? S dot char at I. Okay, so that's going to give us one of our characters. We want to convert that guy to an int. So this will ultimately boil down to an int. And we're going to multiply that integer. We don't need the parentheses here, but we're going to put them in here for clarity. We're going to multiply that by the current value of place. And we'll add that to our running total. So by our example here, this will be the number 4 times 1 gets added onto our sum. Next time through, the number 2 times 10 will get added onto our sum. The number 1 times 100 will get added onto our sum. So when we're done here, we can just return sum. And that's string to int. Make sense? So now to prove this, let's forget about parse expression for a second. We're going to say string num is equal to 124. And we're going to say system.out.println num plus 1. And that should get us 1, 2, 4, 1. There's our 1, 2, 4, 1, proving concatenation. Then I'm going to do this again. But instead of num, we're going to say string to int of num. And there's our 125. Make sense? All right, so first or second grade, third grade math, something like that. That doesn't mean this is easy. Okay? But when we look at that, we broke it down, that one little part, that little tiny baby step. If we only look at that one piece of code right here, that in and of itself isn't that bad. This in and of itself isn't that bad. That guy's getting a little bit juicy, right? Not that bad. Any individual piece here isn't that bad. Like I made a comment last class, something along the lines of all hard programs are made up of a bunch of easy parts. Remember that? Okay, so hopefully we're starting to see that here. And what we're doing is by breaking it down to these little modules like this, we're training our brain to start thinking like this. All right? So now we know how to get a number out of a string. Well, that's going to come in real handy down here, right? Okay, when I'm down here and I'm actually having to do some math, it's going to be great if I have a number, that I have a string I can turn into a number. But before we do that, we're going to write a little helper function. We're going to say static int do math int, let's say string num1, string num2, and then char op. So we now have a function that can take two strings as parameters, presumably those are string representations of numbers, along with an operator, and it's going to do the correct math. Make sense? So let's go ahead and say int a is equal to string to int of num1 int b is equal to string to int num2. All right, now we'll ask some questions on the op. If op is equal to the plus sign, return a plus b. Else, if op is equal to the minus sign, return a minus b. Else, if op is equal to the, well, divide, multiplication, whatever. And do we support modulus or just plus?
The last
Okay.
problem was, oh, not modulus, no.
Yeah, it doesn't matter if you support it or not. I mean, do just add one more thing here. So I'll just do an else here. So the other only other option, assuming that we had correct input, is going to be the division, right? So else will return a divided by b. Okay, if you wanted to support modulus, you could. It's not a big deal. Just one more operator. Support the percent sign or something like that. You can also make up your own operators if you wanted to have made up math. All right, so now we have a function. Pretty simple. Takes in two strings, takes in an operator, uses our handy dandy function we wrote to convert each of those strings into their integer equivalents. Then just ask some questions. If you wanted me to add, I'll add. If you wanted me to subtract, I'll subtract. So on and so forth. Make sense? All right, so that guy's not too bad. He just does math for us. I'm going to kind of minimize some of these things. That's sometimes helpful with this. They have a little tiny drop down where you can kind of hide some code. So I'll minimize that guy so we don't see him right now. We'll minimize char to int, even though that was only a couple of lines. We'll minimize this guy as well. We'll leave that guy open. All right, all the rest of this stuff should be fine. Actually, well, whatever. It's not hurting anybody. Okay, so now let's go back to our parse expression. We know that we are getting our numbers now, right? So we're doing a lot of printing here, so let's go ahead and get rid of some of these print statements to clean this up a little bit. All right, so as we walk through, the first time we hit a non-space, non-digit, we're sitting on an operator. If that operator, if our current operator is the question mark, that means it's our first operator, so we'll just go ahead and set our operator to whatever we just saw. Then we'll set left operand equal to our current number. Finally, we'll set current number equal to 0, ready to build our next number. That's what we do here. Otherwise, we need to do some math, okay? If our current operator is equal to something other than a question mark, that means the number we just read in current number is another number. And we need to do some math between left operand and current number with op. So what do? We say left operand is equal to do math left operand, comma, current number, comma, op. Is it not current number? Oh, this guy's supposed to return a string, so let me. We'll have him return a string. You know what? It's going to be easiest just to have him return an int, like we just had it, and then us just do this down here. So take whatever number, spit out a do math, concatenate it onto the empty string. Now it's a string. Store it back in left operand. All right, so left operand will hold the solution of our math that included left operand. Then we'll zero out current number. We can go ahead and replace op with our new value, right? And I guess keep trucking. Okay, so let's get rid of this guy. set cur number equal to 0 there. That's fine. All right, so that's what we do inside of this else. So either collect a number, skip this iteration, or deal with our operator one way or another. Either collect our first operator and move on, or do some math before we collect the next operator and move on. And as soon as this loop is done, down here, as soon as this loop is done, we've gone through our entire string. But cur number might have something in it. We might not be done with our math. So we need to ask the question, if cur number dot length is greater than 0. If there is a last number built into cur number, we need to do our very last math. Make sense? But consider the situation that we have just that string. We built up cur number, then we exited. Cur number currently has something in it. Its length is greater than 0. But we actually don't have math to do. Because if, right now, our op would be equal to the question mark. We never actually read in an op. So we'll ask the question, if op is equal to the question mark, this effectively means this was a one value expression. So then what do? What's this guy supposed to do? He's supposed to parse the expression. So we can ultimately have him return a string. Well, I guess we can ultimately have him return an int as a number. It's probably what we want to do, have it return an int. So down here, we'll go ahead and return string to int of cur number. Else, we'll just do the final math and return that value. If this was not the case, that is to say, if cur number didn't have anything in it, which actually, is that even possible? Only possible if we gave it bad input. But Java's going to yell at us and say we have to return something. So we'll go ahead and say, we'll throw the else in there even though it's not necessary. And we're going to return string to int of left operand, which should have our running total, our final answer in it. Okay, that's our final answer, and we're going to do that in the event that we don't have a number to do any math with. Reality is, this should never happen unless we fed it bad input, like ended a thing with a plus sign or something like that and never gave it a final number. Okay, so that is parse expression. And then process expression is supposed to what? Take an expression in and print the result, or is it supposed to return the result? Print the result? Okay. So for the homework, static void process expression takes a string expression as a parameter, and we're going to go ahead and say system.out.println parse expression exp. Like that. Okay, so let's test this guy. Process expression exp. This guy should be what? 124 plus 18 What was my next number? Minus 2 times 13. 24 plus 18 minus 2 times 13. So 116? Is that right? That can't be right. Oh, because I do left to right. So we have to force the issue here. So 1,820 is what it should give me. Because we're doing everything left to right in this. 1,820. Looks like we're still doing some printing somewhere. That should fix it. All right, so there's our 1,820 for that guy. Let's feed it some other ones. Let's just do 13. This should just give us 13. Let's do 13 divided by 2. Gives us 6, integer division. Minus 1, something like that, I guess. Okay, now technically I think ours will work for this. So it should still give us a 5. So I said you could assume that the input is correct, but technically that's bad input. Let's see, anything we need to test this on? One issue, this doesn't support negative numbers. We haven't taught it how to read in negative numbers. We could go through and now figure out how minus signs are going to be handled, and if the first digit when we're trying to convert a number is a minus sign, then what are we going to do? We're going to skip it, remember this is a negative number, figure out the integer value of it, and then multiply it by -1. We do stuff like that. Okay, but this is a reasonable approach to the homework assignment. All right, questions on this guy? So which aspects of this were harder than you expected versus easier than you expected? Because understand, even though you've seen the solution now, this guy right here, the parse expression, even though we're not doing anything hard in here, that's a logical flow, right? You know, you think about that guy as like a big filter. So we're dropping a string in there, and that string is kind of dripping through one character at a time, and we need to plinko that one character into the right little places in order to kind of stage our values for us. That makes sense? So that we can do something with them. Was it last class or the class before? Did we look at the Hello World program in Linux assembly in here? The machine language, the assembly code where we staged some things into those hardware registers, then told the kernel to go and find the stuff. Isn't that effectively what we're doing here? Okay, we're storing some crap in left operand, we're storing some crap in op, we're storing some stuff in cur number, we're doing some math sometimes. You know, we're depending on the current state of things around us, we make different decisions to do the right thing based on that state. Make sense? But this guy, even just the logic of this isn't difficult, but because we're beginning programmers, it can get overwhelming. Okay, we look at this as, okay, well, this is, 15 lines of code or something like that for that one part. Well, as opposed to millions of lines of code in like Windows, an operating system or something. So relatively small program in the big scheme of things, but enough going on to intimidate us, right? All right, so let me go ahead and I'll push this to GitHub. I don't have a terminal open.
So if we can add to the string now different additions and digits, so it will still work on the same way?
What do you mean?
Like if we increase the string now.
Like this guy?
Yeah.
Oh yeah, I can do anything I want. What do you want it to be?
But we cannot add some other operands in it, like multiplication or something.
Well,
Or division.
I can put division in here. We support division. Right here, do math. There's division. Division right there. Yeah, and if you wanted to support the mod sign, you could. I mean, you can just put more stuff in here. You know, we can even, I mean, heck, you want to go crazy with it, you can say op equal to here, we gotta make up one. Here, we're gonna do a semicolon, secret operator, semicolon, secret operator. We're gonna return a times a plus b times b. It's a specialty operator where we square both sides and add them. So now we can go ahead and do that. So it supports squaring both sides and adding them. Make sense? So yeah, we can do really whatever we want with it, as long as it's not a negative number right now. Okay, so let's go ahead and check this guy in. Make sure I didn't just break anything. I think we're good. And didn't I even walk through GitHub right at the end of class last time to show how it works? Okay, so I mean, did everybody get GitHub working this last time? Except one guy.
Why GitHub got a little, we can do it in
My computer has problem with
Oh, so it's the computer's fault.
that. Yep, it's not.
I bet you it's not the case. No. It's usually the user. Usually the user. I found computers are rarely wrong.
I completely mess around with this GitHub and the other two. I don't know what happened. There was nothing to fix it.
What homework was this? 3? Yeah, so the actual command I just did there was that guy. I just used some Unix commands to go and look it up because I don't always remember this exact little push dealy. So now if you go to GitHub, we should have that dude up there. Yeah, here's solution for homework 3, just a minute ago. That should have all the stuff in it. All right, so questions about any of that stuff? So far, so good?
But it doesn't look like it was not looking like this complicated question.
What was it?
Like question 4. I
So,
was expecting it would be like not this.
oh, you thought it'd be shorter than this?
Yeah, I was thinking.
Well, it would be if we solved, if we used built-in stuff.
Oh, like those functions.
Oh, yeah, we could do this a lot easier. Yeah, like there's some built-in stuff, but yeah, I don't want to show you some of it yet.
This is
Still gotta use our fingers to figure out.
That's right.
how we're all doing
yeah,
it.
like going through the problem. This is like literally going through
Yeah, wasn't this fun?
Yeah.
So when you did the homework, you enjoyed it, right?
I enjoyed it up
but
until
not
this
one.
part. And
Not,
then
not this one.
Up until the part where I wrote my first curly brace. I was having a blast.
It's so good. You feel so good when you do some stuff and it literally works. And but when you got stuck somewhere and it just paid.
for me, it was just order and how you processed it. I mean, I understood the fact that you wanted to break it down into little pieces,
Mhm.
but it's how the order of how you break it down in those little pieces and process each one. You pull up the Boolean expression in one of your static statements there, or one of your methods, and it's all of a sudden or it was down further. You had a Boolean method.
Oh, the is digit?
Yes.
This guy.
All of a sudden that was like, oh, it was that easy. It was like,
No, I get it.
you.
But that's, first of all, that's why I teach the class the way I teach it. Because it's almost like a magic show, right? I'm sitting up here, I'm doing something you guys spent a lot of time on. And it doesn't seem that bad while I'm doing it. That doesn't mean it's easy. I've been doing this for a few minutes. But the reason I do live programming in class is so that you could see that it's doable. Okay, that it's possible to sit there and just solve problems like that. And when you get a competency in it, then it becomes your go-to tool. And this is actually really important, I think, for IT professionals. And that's kind of what I brought up, I think, on the first day of class. Is fine. You're not necessarily always solving problems like this, but you know what? Sometimes you need to do something that's really tedious. That if you have a handle on software development, you could just say, well, I'm going to write a little script that's going to just do this for me. I'm going to spend 20 minutes, I'm going to write the script, and I'm going to go home while this thing works overnight. Parsing out a log file or something like that. So having this skill set is incredibly powerful. Makes some sense? Okay. But it's going to take practice. Brought that up the first day of class. Think about it like a sport. It's like that, isn't it? I haven't been golfing for that long. I've been golfing for, I think, 7 years. So I've gotten good pretty quick. But I tell you what, I loved it the first 2 years, but I think it was this feeling that you're having. It's like, you hit one good shot. It's like, oh my gosh, I can do it. I'm capable of doing it, right? And then you mix it, you follow it by 1,000 shanks. Okay, but it always that one shot that keeps you coming back. But I practiced, and I practiced, and I practiced, and I practiced. And now I rarely hit, embarrassing shots. I mean, I don't always get it on the green each time and stuff like that, but I'm pretty good at it. But that's not because I'm just naturally woke up and I'm an awesome golfer. It's because I drilled so many times that I've forgotten how to hit horrible shots. I can now usually hit at least mediocre plus shots every single time. So that's kind of what we're moving towards. So it was good that you spent plenty of time on this assignment. Next one will be worse. Oh my gosh. No, but here's the reality. The reality is the next one will actually be a substantially harder assignment. But you're going to find it about equally as hard as this one. Because now you've seen a process and you're going to be able to apply this process to the problem. And things that, if you could do this assignment over right now, it would still be challenging. But it would probably be a degree easier than it was the first time around.
No, because you broke it apart in steps.
Sure, but even if I didn't give you the code, if I sent you off and said, do the assignment again after you've seen it, you now have a model you can follow for breaking it down into tiny steps. You're still going to struggle. It's still going to be difficult, right? Because you don't have the practice in yet. But you now have seen that, oh, he broke it down that granularly. I figured maybe we break it into 2 or 3 functions. He did 9 to break it down into a bunch of little tiny steps. Okay, so let's go back in here. Let's talk about, so we just did this guy for number conversion, right? Okay, and we said we wanted to convert this guy from the string representation of a base 10 number to a to an integer representation of a base 10 number. Let's look at binary numbers. We talked about converting binary numbers in here yet? Okay.
This is what you're talking about with doing base though.
Yep.
With bases.
So let's say we have that binary number and we want to convert that to decimal. So binary to decimal of this number. We start at the end. This is the ones place, 2s, 4s, 8s, 16s, 32s. Ones place, times 2, times 2, times 2, times 2, times 2. Just like we were dealing with a decimal number, it was ones place, times 10, times 10, times 10, times 10. If it's a hexadecimal number, it's ones place, times 16, times 16, times 16. They're all the same. Every single one of them. All right, so we want to write a function. So let's look at this. So this is going to be 1 times the ones place plus 0 times the 2's place plus 1 times the 4's place plus 1 times the 8's place plus 0 times the 16's place plus 1 times the 32's place. Okay, and we add all that up. This is 32 plus 8 is 40, 44, 45. This should be the decimal number 45. That guy? Okay, because why? We were able to ignore all the zeros. 0 times anything is going to be a 0, right? All right. So let's go ahead and write a function called binary to decimal that takes in a string representation of a binary number and spits out the decimal equivalent. Okay, so for starters, let's just get rid of all this stuff. He just deleted all that gold. All right.
It's on video.
It's on GitHub too. All right. What am I doing? Yep, so we're going to write a function here. Static void main. I wonder what this guy's complaining about right now. Oh, he was like hidden. Okay. It was from the, he was still compressed. I still had one of my things a little bit dangerous, I guess. All right, so we're going to say static binary to decimal. Whoa. And this guy's going to take in a string bin for a binary number. And we are going to convert that number to decimal. Well, we're going to keep track of the place. The place is always going to start off the ones place. We're going to have a sum. That guy will start off at 0. So we have to sum stuff up. We just look at how we did it here. We're definitely summing some stuff, right? So whenever we do sums, we start off a base of 0. Whenever we do multiplications, we start off a base of 1. That way, the very first time you multiply anything by 1, you get the anything. So that becomes your starting point. All right, we're going to go through our string from end to beginning. That's important because we don't know how many characters are in bin necessarily. We don't know what place it's going to go out to. Is it the 32's place, or the 64's place, or the 128's place, the 256, so on and so forth. We don't know. Okay? So remind me, how many characters are in bin?
You don't know.
How many characters are in bin? Bin.length. There's bin.length number of characters in bin. Right? This is a function, method, untapped resource. All right, so whoever calls this is going to pass us something. How do we get the number of characters in it? It's bin.length. So we're going to go from the very last legal character, which is bin.length minus 1, all the way up, well, all the way down to and including 0. So for int I is equal to bin.length minus 1, so that's the last legal position. Keep going as long as I is greater than or equal to 0. subtract 1 from I each time. All right, and each time through, we're going to ask the question. If bin dot charat I is equal to 1, that means we're going to keep it. If it's a 0, we're not going to do any math, right? Okay. What happens if I multiply any number by 1? What do I get? The any number. So do I even have to do multiplication if I see a 1, or can I just keep it? Can't I just say, well, if I'm currently looking at a 1, I'm just going to say sum is equal to sum plus place. Because place times 1 will be place, won't it? If it's the 16's place and we're looking at a 1 there, 1 times 16 is 16. So why waste our time doing the multiplication? If it's a 0, I'm not going to do anything, right? Just skip it. Okay, and this guy is going to return for us a integer. So binary to decimal takes in a string representation of a binary number. We'll start our place off at 1, start our sum off at 0, walk our binary number from the end towards the beginning, asking the question each time, if the current character we're looking at is a 1, add it onto our running total. We'll add our place onto our running total. Now what are we missing here? Purposely left one line out. This guy is a function. This guy's going to return a value. He's not printing anything. There is something logically broken with this code right here.
To add those decisions.
I want you to read the code, not just randomly guess. Why won't this work? I'm not updating place. Each time through, the value of place needs to be doubled. I need to say place is equal to place times 2. Whether I did multiplication or not, place needs to be twice as big as it was the previous time through. Make sense? So place times equals 2. I think I showed you that syntax last time. Compound operator. So place times equals 2 is the same thing as saying place is equal to place times 2. Those are synonyms. All right. So if I run this program right now, what will the output be? Nothing. Why? All programs begin and end with main, and there's nothing in main. I have a fairly complex function that I never call right here. So we're going to go ahead and call it. We'll give it our 101101. So we'll say system.out.println binary to decimal 110. Oh, was it 101101? Like that? Okay. And we said this should be a 45. Oh, missed it. There's our 45. Okay. So now we have a guy that works for converting binary numbers to their decimal equivalent. Not too shabby. Okay, well, so let's static int octal to decimal. String oct. What are the legal digits in a base 8 number? 0 to 7. Base 2 number is 0 and 1. Base 10 number is 0 to 9. Base 8 number is 0 to 7. Make sense? Okay. So I want to write, I kind of butchered that, right? Octal. Octal to decimal. This guy should take in a string an octal represented a number in string format, an octal number in string format representation, and then I want to convert that guy to decimal. What's the difference between that and what I have right here? Will I convert an octal number? So let's go right here. So what's your favorite octal number? 68?
No.
What?
16, 32.
Okay, so you're okay with that? All right. So why couldn't I say 68? It's not an octal number, right?
64.
Yeah, 64 would be okay. That's an octal number. So it can only contain the digits between 0 and 7. Okay, so this is an octal number. This is the ones place. This is the eights place. If I had another guy in here, this would be the 64's place. We're multiplying by 8 each time, right? So this would be 4. Well, actually, I think I was doing like this. 1 times 4 plus 8 times 6 plus 64 times 2. So that's 128 plus 48. 176, 180, right? I think that's the number 180. Okay. So we're going to write that program. What was the difference? Instead of multiplying by 2, we multiplied by 8. Okay, so we can just basically take this code, paste it in here, change that to 8, and we're good to go? Well, except we need to change all the bins to ox. Now we're good to go?
Because we were just.
No, because you gotta change your character at, it's looking for a 1, right? Yep. So you're gonna have to change it to look for other characters, 0 through 7.
Oh, additional characters. Well, I don't need to look for the 0.
No, but you have to look for 1 through 7.
Yeah, 1 through 7. So do I just copy and paste?
Can you copy and paste it?
Yeah, should I just do that? Should I do this? And just throw an else in there and say, well, if it's equal to a 2, then we'll say 2 times place.
No, because your second place is gonna be.
Well, it should just be 3.
We cannot make some for function to 1 to.
And this will be 4.
No,
5.
because
6. 7. And what was my test number? 264. There's our 180. That seemed a bit tedious, didn't it? So using only what you know at this point, minimize this. How can I update this code to make it more compact and less tedious? Because I tell you what, if we go on to base 16 this way, it's going to start.
you change your place. I mean, you check for your place.
She wants to use index of. I know what my place is. My place is always going to be 1 or 8 or 64 or, what is it, 256? How do I find out the numeric value of that? We've already done it once. Didn't we have a function we wrote a little bit ago called decimal to, or what, I'm sorry, char to int? Didn't that just use the index of, right? So a little helper function here. So we can say static int char to int. This guy took a char as a parameter. And oh, I forgot. How do we do it? If I take it a char 7, how do I return the number 7? That's all this guy's supposed to do. He's supposed to take in something that looks like that and return that. All right, so you want to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Nope. 8 and 9.
Why?
Because you're working with base 8. You
Well,
don't need
this
8.
function is just called char to int. Might we want to convert any char to an int? Isn't this going to be handy for other bases?
Yeah, probably.
It's just a tool, right? Yeah, I mean, we likely are not going to pass him 8s and 9s if we're dealing with octal numbers, but it doesn't hurt us to pass him 8s and 9s, right? Index of C. Return that. So if this was a 7, we're going to go through here, we're going to find the char 7, and that happens to live at position 7 inside of that string. Make sense? So this guy converts a char to an int. So just like that. We don't need any if statements now. Can we make the binary one work this way? Can we just plop this down here? Change bins there. Just multiply by 2. Does binary work again? So 1 0 1 1 0 1. Is that our example? Into decimal.
Binary, you gotta write it all.
Oh, I didn't call it bin. All right. There's our 45. But decimal to decimal. Same thing. Doesn't matter what the base is, converting it from that base to decimal is the exact same algorithm. So, couldn't we write a version of this? Just steal this. Maybe call this guy base to decimal. Maybe this guy takes in a val string and it takes in a int. Usually this is called a radix. called a base radix. So a base 2 number has radix 2. Base 10 is radix 10. That's a math name. So we'll always multiply by radix. Here's val. Here's val. So that's base to decimal. So now we'll call base to decimal for each one of these guys. And we'll pass it the appropriate base. This was base 8. This was base 2. This was base 10. There's our same output with one function. So we can get rid of all these other ones. That make sense? All right, so just keep trucking then. Now we'll call base 2 decimal. Well, it's going to be 16. 16 breaks it, but that's something to. So we're going to start with 2569. No, actually, let's do 25. So we want to convert the number 2589 from base 16 to base 10. Well, so that says it's 9609. $29.89. That's 9 times the ones place plus 8 times the 16's place plus 9 times the 256 plus 2 times the 4096. Okay, so that's 4096 times 2 is 8184. Plus 9 plus 8 times 16 is 128. Nine times 256 is 2304. Okay, so then I'll just steal this line right here. 10,625. All right. Well, we're even more wrong here.
Yeah. So you would actually have to expand your character. You'd have to include those base 16 characters.
Yeah. So legal digits in base 2 is 0 and 1. Legal digits in base 8 is 0 to 7. Legal digits in base 10 is 0 to 9. Legal digits in base 16 is 0 to 9, then A through F. Make sense? Okay. So if I try to run this on that, I get a very wonky result. Why do you think it went negative? When I tried to pass a D into char to int, what did it give me? -1. Doesn't see a D in there. There's no D's. So I get a -1 out of there. Not going to work. What if I go in and I put A, B, C, D, E, F? That works. It can convert those guys. Now it knows to treat the D as a number. It knows to treat the B as an 11. The A as a 10. So on and so forth. That make sense? Okay. So now we have base to decimal. And I can certainly finish out the alphabet. And then let's go ahead and break it.
You guys know how to read the,
Lowercase. Lowercase b. What am I supposed to do about that? Well, I'll introduce you introduce you to a new string method. So base to decimal, what we're going to do here is we're going to say val is equal to val dot to upper case. So whatever string gets passed in, we'll convert it to uppercase. Now we're back to 2989. We assume all of our letters are in uppercase, so we support that assumption by just setting val equal to the uppercase version of himself. So this is a function that's owned by the string class that takes no parameters, called toUpperCase, that seemingly converts a string to uppercase. Make sense? But notice that he returns a new string that is the uppercase version of the string that called it. He is not changing val permanently. So if I just do this, if I say val dot to uppercase like that, it's still broken. Because val did not permanently change. I boiled down to an uppercase string, a string like val that's in all uppercase, and chose to store it nowhere. So val went on being his old self. Instead, I can choose to overwrite the current value of val with his uppercase version. $29.89. Okay. Questions about that? If you notice here, I haphazardly picked 2989. It's my favorite hexadecimal number. Well, BAD is. That's the conversion. All right, so let's say I have 2989. Well, actually, let's start with an easier number. Let's say I have the number 45. And I want to convert that from decimal to binary. How do we do that? Well, I divide it over and over again. So I take 45, divide it by 2. How many times does 2 go into 45? 22 times? So 22 times 2 is 44. So this is remainder 1. 22 divided by, that's 11. 11 times 2 is 22. Remainder 0. 11 divided by 2. 5. 5 times 2 is 10, with remainder 1. 5 divided by 2. It's 2. 2 times 2 is 4, remainder 1. So 2 goes into 5 2 times, remainder 1. How many times does 2 go into 2? Once. 1 times 2 is 2, with remainder 0. How many times does 2 go into 1? 0 times. 0 times 2 is 0, with remainder 1. You read the answer from bottom up. 1, 0, 1, 1, 0, 1. I always pick bad examples like that read the same forwards and backwards. I have a terrible habit of that. Trust me, this one right here is this one. Here. Now we have a better example. All right. That makes sense? And what do you think about converting a, what was our other example here? 264? 264 octal. Actually, I'm sorry. Our number was, what did it come out to? 180? I think it was 180. 180 des to octal. What do? Take the number, divide it by 8. How many times does 8 go in 8 go into 180? So 180 divided by 8 is 22. 22 times 8 is 176. So that's remainder 4. 22 divided by 8 twice. 2 times 8 is 16. Remainder 6. 2 divided by 8, 0. 0 times 8 is remainder 2. Notice we're done every single time we hit a 0 here. Read the answer from bottom up. 264. 264. Exact same math, right? Identical math. So, I keep dividing the value by the base over and over and over and over again until I get an integer division of 0. That tells me when I'm done. Each time I need to record the remainder. Make sense? All right. How do I record the remainder? How would you suggest I do that? Store it where? Okay, well, how many integers are we going to need? I needed 3 here. If my number got any bigger, I might need 4, or 5, or 6, or 20. Don't know about those yet. We know about something kind of like an array. Been using it a lot today. Strings. Can't we just concatenate crap onto a string? And since I read it from bottom up, it might be helpful to concatenate it on backwards. Right? That way I don't have to reverse it in the end. But we could certainly reverse a string, couldn't we? We could just write a function to reverse a string. We're function experts now. So, let's start off with the binary one. So we'll say, right above this guy, static string decimal to binary. And let's have this guy take in 45, for example. We're hoping it produces the other guy. Well, that's just dumb. Int val, we're going to test it with 45. All right, so what we're going to do is we're going to divide val over and over and over and over again until it finally has a product, or I'm sorry, a quotient of 0. So, while val divided by 2 is not equal to 0. Okay, I'm sorry, not equal to 0. Well, that's a true statement. We're going to be building our answer onto this. So what are we going to do? We're going to say answer is equal to the empty string concatenated with val mod 2 concatenated with answer. So we're building it backwards, tacking that thing onto the front of it each time. And then we'll say val divide equals 2. Return answer. Decimal to binary 45. What happened?
We're missing one. We didn't finish it.
Ah, we have one last little dude there, don't we? So we bailed out as soon as it was equal to 0, but we didn't do the very last piece. And what's the very last piece? The very last piece is the final remainder. Make sense? So that's decimal to binary. What about decimal to octal?
Pop in an 8 instead of a 2.
Divide by 8. Divide by 8. Mod by 8. And that's what, 180 was our test. Oh, last one. There we go. Decimal to decimal? $237 to $237. All right. Base to decimal. It's going to take in a vowel and a radix. We'll divide by the radix over and over again. All right, so now we can switch all these to base. And this is base 2. This is base 8. This is base 10. Base to binary, base to octal.
Maybe base to decimal.
Oh.
You have that one named.
Oh, yeah, I just named it stupid, right? This should be decimal to base. That's what this should be called. Okay, all our same values until you can almost see the BAD in there, but the 11 should be a B, the 10 should be an A, the 13 should be a D. So close. How do we do that final mapping? This is where we're concatenating on. This guy right here is coming up with an 11 or a 10, something like that. I need to convert that value into a char, maybe. Let's say into char. So we can say static char int to char. This guy's going to take an int num as a parameter. And it should return the char 0 for the int 0, the char 1 for the int 1, the char 9 for the int 9, the char a for the int 10. How do I do that? And we'll take our break after we get this. You think this is a hard problem?
No, it'll probably be simple once you.
One line. Of stuff you know. Stuff that we've already covered. I believed in her too soon. Before, when we did the mapping, we did an index of mapping, right? We said, give me the position of the 0. Was that bucket 0? Give me the position of the A. Was that bucket 10? Well, what if I want to get the A given a 10? Char at 10 gives me the A, right? So I'll just say, well, I could stop there. I could just keep going with the alphabet. Dot char at num. And we're going to return that value. So then we'll always say int to char. It does. A, B, C, D, E, F. A, B, C, D, E, F. This is 10, 11. That should be a B. Oh, we have to do it down here too. There we go. We just weren't doing it in both places. So now this will convert from any base to any base up to 16. If we want it to work for the whole alphabet up to base 37, we just add the rest of the alphabet in. Make sense? All right, let's take a 20-minute break, and then we'll come back and do the stuff we need to move towards for our impossible homework.